Welcome to The Explainer. I am so incredibly glad you're here today because we are going to unpack a truly fascinating, high-stakes topic. It sits right at the intersection of modern technology and global maritime security. We're looking at the hidden vulnerabilities of modern maritime navigation. I mean, think about it. We live in a world where we trust the glowing screens on our dashboards implicitly, right? But what happens when those screens suddenly go dark? Or even worse, what happens when they actually start lying to us? Today, we are exposing these invisible threats, GPS jamming and spoofing. To really grasp the real-world stakes right out of the gate, consider this totally stark warning from the International Maritime Organization. The IMO has officially warned that global navigation satellite system interference is rapidly increasing worldwide. And let me be clear, this isn't some science fiction movie plot, and it's not a rare hypothetical scenario. This is happening right now, particularly in areas of high geopolitical tension and along some of the world's absolute busiest shipping routes. The entire foundation of global trade relies on massive vessels knowing exactly where they are, and frankly, that foundation is currently under attack.
Okay, let's dive into our roadmap for today. First up, we have the fragile lifeline. 2. Jamming, the blockade. 3. Spoofing, the deception. 4. Spotting the difference. And finally, number 5, the ultimate defense.
All right, part 1, the fragile lifeline. To really understand the threat, we first have to recognize our absolute, almost dangerous reliance on satellite navigation systems. Picture this. You're standing on the bridge of a massive commercial cargo ship. You're navigating through a tight, hazardous strait, and your GPS is basically feeding you everything. It gives you your exact position and latitude and longitude, your speed over ground, your course over ground, and highly accurate UTC time. It's a remarkably efficient system. But, it also means a vast amount of critical, life-saving information is coming from one single source. It is the literal definition of putting all your navigational eggs in one basket. And here's the really wild part. The core physical vulnerability of this whole setup just comes down to physics. GPS signals are incredibly weak by the time they travel thousands of miles from space all the way down to Earth. Because the signal arriving at the ship's receiver is so faint, it's inherently vulnerable. It really doesn't take a massive amount of power to drown it out or manipulate it. And that physical reality, that is the gateway for our very first major threat. Which brings us to part 2, GPS jamming, the blockade. So, what actually is it? Well, GPS jamming is the intentional, or sometimes totally unintentional, transmission of radio frequency signals on the GPS frequency to block or overpower genuine satellite signals. Think of it like a blindfold. Imagine you're standing in a crowded room trying to listen to someone whispering to you from across the room. That's the satellite. Suddenly, someone right next to you turns on a megaphone blasting static. You can't hear the whisper anymore, right? The ship's receiver simply stops working entirely because it just can't get enough data to calculate a position.
So here's how this plays out in real time and builds into a crisis. Step 1. Those satellites transmit the super weak signals we just talked about. Step 2. A local jammer emits powerful RF noise on that exact same frequency. Step 3. The GPS receiver gets totally overwhelmed. It just cannot distinguish the real faint space signals from the loud local noise. And finally, step 4. The navigation data is entirely lost. The screens completely lose their fix.
So you might be wondering, who or what is actually turning on that megaphone? The causes are incredibly diverse. On the intentional side, you've got military operations, terrorism, and criminal activities, like smuggling, where perpetrators deliberately want to hide their movements. But a really crucial point here is that jamming isn't always some malicious geopolitical act. Unintentional jamming is actually highly common. It can be caused by faulty electronic equipment, radar interference, or honestly just general electrical noise from nearby comms gear.
When this blockade hits, the symptoms on the bridge are immediate and, let me tell you, highly stressful. Alarms start blaring, you get a no position fix warning flashing at you, the electronic chart display, the ECDIS, loses its GPS input. The automatic identification system, or AIS, becomes completely unavailable, meaning other ships might suddenly struggle to see your digital footprint. Your radar overlays vanish, and even your digital clocks might show the wrong time. Without swift action, this sudden loss of situational awareness can rapidly lead to a collision or grounding. Now, while jamming is incredibly stressful, it is obvious, you know you're blind. But that escalates attention to a much more insidious threat.
That brings us to Part 3, GPS spoofing, the deception.
Unlike jamming, which is a blindfold, GPS spoofing is a straight-up hallucination. It's the transmission of false GPS satellite signals that literally deceive a receiver into calculating an incorrect position, speed, or time. During a spoofing attack, the ship's GPS receiver keeps humming along, working perfectly. No alarms go off. The digital screens look completely normal, but the reality those screens are presenting, it's an absolute lie.
The mechanics of this attack are elegant but incredibly dangerous. Step 1. A fake GPS transmitter creates perfectly crafted, counterfeit satellite signals. Step 2. These fake signals are broadcast just loudly enough so they appear slightly stronger than the genuine, weak space signals. Step 3. The ship's GPS receiver naturally drops the weaker true signals and happily locks onto the stronger fake ones. And Step 4. The receiver calculates a completely false position. The navigator might believe the ship is cruising safely in deep water, while the attacker's fake coordinates could actually be steering them directly toward a reef.
Because the computers think everything is totally fine, the symptoms of spoofing are deeply surreal and confusing for a crew to deal with. The ship's position on the electronic chart might just suddenly jump. A massive cargo ship might appear to be sailing across dry land on the monitors. You'll see the ECDIS route displaced, or the radar overlay will be entirely misaligned. Honestly, the most terrifying symptom is when the GNSS position flat-out disagrees with what the navigator is seeing with their own two eyes out the window.
Okay, Part 4. Spotting the difference.
So, when things start acting super weird on the bridge, how does a highly trained crew actually diagnose what they're facing? Well, comparing the two side by side, the core purpose is clear. Jamming aims to block, while spoofing aims to deceive. Looking at receiver status, in a jamming event it stops working entirely, but with spoofing, it continues working as if nothing is wrong whatsoever. The position output in jamming is clearly none, but in spoofing it feeds you a false position. And this leads directly to detection difficulty. Jamming is easy to detect. Your screens go blank and alarms yell at you. Spoofing is incredibly difficult to detect because it actively lies to the navigator. If you're wondering which is more dangerous, it is without a doubt spoofing.
And finally, Part 5. The ultimate defense.
So, if the tech we rely on every day can be blinded by jamming and completely hijacked by spoofing, what on earth do we do? Well, the solution to these high-tech digital threats is surprisingly analog. When the digital screens fail, or worse, when they lie, good old-fashioned human vigilance saves the day. A well-trained bridge team has a robust arsenal of independent navigation methods that literally cannot be digitally spoofed. They use radar, ranges, and bearings. They step out onto the bridge wings and take visual bearings of lighthouses and headlands. They check the echo sounder to make sure the physical depth of the water matches the chart. They use parallel indexing, traditional dead reckoning with a speed log and a gyro compass, and hey, even celestial observations using the stars. You absolutely cannot hack a physical visual bearing, and there is no way to spoof the actual depth of the ocean floor.
The UK Maritime and Coast Guard Agency exam guidance states it absolutely perfectly. A navigator should never rely on GPS alone. This right here is the golden rule of modern seafaring. Whether it's a cadet trying to pass an oral exam or a seasoned captain steering a massive tanker through a contested strait, the principle is exactly the same. Technology is an amazing tool. It's an aid to navigation, but it is never, ever a replacement for good seamanship and continuous independent verification. We've seen today how easily our fragile digital lifeline can be severed by jamming or completely twisted by spoofing. The screens we trust so much can simply go dark, or they can become instruments of deception. So I want to leave you to reflect on this one thought. In a world that is increasingly ruled by satellites, complex algorithms, and digital convenience, is your own human situational awareness the only true compass you have left? Thank you so much for exploring this fascinating topic with me. Keep verifying your bearings, and I'll see you in the next explainer.